Good morning, good afternoon, or good evening, as the case may be. All right. Today, I'm going to look at the sine rule and at the cosine rule. We're also going to look at some other pieces regarding areas with this as well. Okay. For the sine rule, it's a very useful property that can be proven using simple trigonometry. It's also known as the law of sines. Okay. So the sine rule, law of sines. It's given by a proportion, and it's in relation to a triangle, right? So if I know the angles of a triangle and the sides of a triangle, right, I can figure out other information. There are going to be three situations where we use the sine rule. Okay. The situations are if we know two angles and a side, not between the two angles, or if I know two angles and a side between those two angles. The other situation we will have, the third one will be side, side, and angle. All right, so if I have a triangle where I'm provided with two angles and a side, or I'm provided two sides and one angle, and the angle is not between the two sides, I'm going to be able to use this sine rule, which also gets called the law of sines. Okay, so how does it work? Let's look at a few examples, and then we'll let you practice it on your own. Okay, we have no ambiguity if we know two angles. What does that mean? If I know two angles, then it's very quick to determine what the third angle is, right? In this first case, how would I find the third angle? Well, I know that my angles add up to be 180 degrees. So what does that mean? What that means for us is that if I take 180 degrees for my triangle in this two-dimensional space, and I subtract the other two angles, then I know my third angle. So in this case, that third angle would be 92 degrees. Now, clearly, if this angle is 92 degrees, this triangle is not drawn to scale. Right? But there's no ambiguity. We know the three angles. In this situation, if I were to do the work, I would put 180 minus 36 minus 22, and I get 122. Right? So this angle over here would be 122 degrees. Okay? Now, there's no ambiguity there, right? If I know two angles, no ambiguity. Also important to note that in this work with the sine rule and this work with geometry in this unit, and when we do navigation with navigation, we will almost always be using degrees. So it's going to be important to remember those degree symbols. Okay, so let's go ahead and solve these triangles. Everything's going to be based on working with these proportions. So let's see how we're going to set this up. If I label these two sides x and y, I can get the following proportional equation. The equation that I get is x over the sine of 72 degrees is equal to 3 over the sine of 16 degrees is equal to y over the sine of 92 degrees. Okay, just putting the items, right? Then where does that come? X over 72, 3 over 16, 92, and y. Okay, so y over 92, excuse me, side over. Okay, then I can solve for my missing information. And so solving, right, multiply this side by sine of 72, 3 sine 72 over sine of 16. Over here with this equation, multiply by sine of 92, 3 sine 92. And I can go ahead and evaluate that. Now, before I go and evaluate, I'm going to want to make sure that my calculator is in degree mode because most of our work is going to be done in degree mode. So I can enter in the information into my calculator, 3 sine 72 degrees divided by the sine of 16 degrees. And where I get that degree symbol, if I move this up just a little bit, I'm going to hit the second key and apps, and there's my degree symbol. Always good practice to use that degree symbol. So I put that in. There I have my value for x, and I can do similar to find my value for y. And notice that if I know I am in degree mode, which I am in degree mode. If I know that I'm in degree mode, I don't need the degree symbol, but it is usually good practice. And I can find my value for x, and I can find my value for y. So let's go ahead and write those down. So our value for x and our value for y, 10.4 and 10.9. Notice the biggest angle is 92 degrees, and the longest side is the side opposite that, y. Okay, the shortest side is 3, and the side opposite that is the angle opposite that is the smallest angle. So there we have our information, right? That is how we do this work. So let's go ahead and set up that next problem. Here is what we have, right? We want to solve the triangle, and when it says to solve the triangle, you need to find the missing sides and the missing angle. Here we've already found the missing angle, right? So I can come over here, I'll just go ahead and label this x, label that y, and let's get the equation set up. So here we have our equation, right? That the side over the sine of the angle, side over the sine of the angle, side over the sine of the angle, right? And I want to find the missing side lengths so I can solve the triangle. So I set up my equations. Here I have 4 sine 22 divided by sine 122, and over here 4 sine 36 over sine 122. Put those into my calculator. And y as 2.8 inches. Once again, notice here our biggest side, biggest angle, right? Smallest angle, smallest side. Okay, that's it. That's the law of sines, right? It's fairly straightforward when you know two angles. Nothing really too hard there, right? What occurs though is that we do have an ambiguity possible if I only know one angle. If I only know one angle, then I may have trouble determining what the other two angles could be. However, that doesn't mean that I could have trouble, means I always have trouble. So let's look at this situation. Okay. So if I go ahead and label my information here, it asks me to determine the length of the missing side. Well, the missing side, I've just labeled x over here, right? But I don't know two angles, and in order to use the law of sines, right, I need to know a little something, right? So I can't directly use x over the sine of alpha to find my value. First, I need to find this angle over here. I need to find this beta that's opposite this 4 that I know. That way there's only one piece of information that's missing. So let's go ahead and do that. So if I rearrange the right side of this equation for a sine of beta, I get that sine of beta is equal to 4 sine 34 divided by 6. All right, so I have 4 sine 34 all over 6. Let's go ahead and put that into our calculator. Okay, so I put that into my calculator, 4 sine 34, and then divided by 6, and I get this value, 0.3727 approximately, right? So I'm going to go ahead and write that down. So now that I have it written down, I need to figure out this value for beta, because if I can figure out the value for beta, then I can figure out alpha, and if I can figure out alpha, I can figure out x, that missing side. And to figure out beta, I'm going to use the inverse sine function on my calculator, right? So I'm going to come over here and say, hey, the inverse sine of that answer that I just had. So the inverse sine of that answer that I had to the nearest tenth would be about 21.9 degrees. Now, if I look at beta and I say, hey, could beta be 21.9 degrees? Well, what do we know? We know that beta is smaller than 34 degrees, right? We know that beta is smaller than 34 degrees. Why? Because, excuse me, writing that incorrectly, because 4 is smaller than 6, right? 4 is smaller than 6, so beta has to be smaller than 34. Well, this angle, 21.9 degrees, is less than 34, so it's going to work. Right? The reason we call this an ambiguous situation at times is that we have to recognize that 180 minus 21.9 degrees has the same sine ratio, right? That if I were to come over here, right, and I say, hey, what is the sine of 21.9? And what is the sine of 180 minus 21.9? I'm going to get that they have that same ratio, right? Because recall from all the work that we've been doing that if I have an angle, right, over here that's 21.9 degrees, and another angle over here that's 21.9 degrees less than 180, I'm going to end up at the same piece, right? Now, this obtuse angle would not work in this situation. We know this angle has to be less than 34, so we know the answer has to be 21.9 for beta. Okay, but we're not done yet, right? We're asked to find the missing side. We've only found beta right now. So we need to take 180 minus that 21.9 and minus the 34 to get this 124.1. So now alpha is 124.1, but we still haven't found our missing side length. Now we need to solve for x. So let's go ahead and set up that equation. So we set up the equation over here where we have some space. We know that x is going to be 6 times the sine of alpha divided by the sine of 34. Well, that's 6 sine of 124.1 all over the sine of 34. And we go ahead and compute that value to be. Let's see. Put that in the calculator. So we get that that value for x is about 8.9. Right? And in this situation, once again, we're working in inches. So boom, there we are. All of that work, not too difficult, but multiple steps, going to be important that you can do. Okay, so far, we've only done situations where we knew what our answers were and really didn't have any ambiguity. In the next video, we'll look at where ambiguity arises.